Whoa! That guy is amazing! He absolutely defies gravity!
Nobody defies gravity, not even slam dunk champions. Let me tell you what's really going on.
Uh-oh. You're not gonna get all scientific on me, are you?
Hey, this just might make you a better basketball player.
I'm all ears.
Okay, so when that power forward jumps, he pushes off the floor with lots of force. That gets him moving. And because of inertia, he keeps moving in the same direction.
Higher and higher.
Until the force of gravity pulls him back down.
Total bummer.
Not really. Without gravity, you b-ball stars would have a hard time making baskets. Because when you jumped, you just keep going, out into space.
We'd be playing moonball. So, how does gravity really work?
Well, most people think that gravity's just the pull of the Earth.
Right. It holds everything on the ground and keeps us from floating into space.
That's true, but there's more going on.
Like what?
Okay, all objects attract each other. That means the Earth's not only pulling us, but we're pulling the Earth.
Come on. I don't see the ground coming towards us, do you?
No, and there's a good reason. It has to do with mass and gravitational force. The force of attraction between any two objects.
Like the Earth and my basketball?
Or the Earth and the Moon. Any two objects.
Yeah?
Definitely. And it pulls from the exact center of each object's mass.
The center of gravity?
Exactly. So, for the Earth and other spheres, the center of gravity's right in the middle.
For my basketball too?
Yep.
What about things that aren't spheres?
Everything's a bit different. You can find the center of gravity of a pencil by balancing it on your finger. The place where it balances is the spot.
Okay. And the bigger objects pull harder?
Well, it's hard to believe, but any two objects attract each other with equal gravitational force.
You're kidding. How about a basketball and the Earth?
Strange, but true. They're attracted with the same force.
That's wild.
But they react differently to the force. Because they have different mass, the Earth is gigantic compared to a basketball.
So, mass is the key.
Yep. Imagine if I tried pulling an elephant. It's so heavy that it's got a lot of inertia, so my pull isn't strong enough to start it moving. But if I pulled this puppy with the same force, it'd come right to me.
Right. It's got less mass and inertia, so it's easier to move.
Well, it's kind of the same with gravitational force. Big, heavy objects barely feel the attraction, but objects with less mass are pulled towards the bigger ones.
You mean basketballs, people, puppies, and other things are pulled towards the Earth because they're so much smaller than the Earth?
Yep, that's what gravity's all about. In fact, the moon's small enough to react to the pull of the Earth's gravity too. But since it's pretty massive, it stays in space instead of being pulled to the ground. If it was the size of a basketball...
It would be pulled straight to Earth. Wow! I think I'm getting it. Gravity's the pull that keeps objects on Earth from floating into space. But it depends on gravitational force and mass. Gravitational force is the physical force that attracts two objects towards each other. It pulls from each object's center of gravity, the exact center of its mass. When two objects attract, they pull with the same gravitational force. Objects with less mass feel the gravitational force more, so they're pulled towards larger objects.
RJ, you're a real science whiz.
Yeah, well, I'm definitely attracting some new ideas into my head. Huh.
2 points.
For me and gravity.